What if I told you that we had discovered a brand new solar system? A solar system so unique and interesting that it has been recreated in its entirety by artificial intelligence. What would you expect to see when you first laid eyes on this place? Would you imagine a cluster of rocky planets very similar to our own? Or perhaps you'd picture something wholly alien and strange. Either way, prepare yourself for Stellar Journey 2.0, an incredible recreation of our solar system made by Google DeepMind and released in early access on June 26, 2023. This one is not like any other game or simulation out there. In today's video, we are going to be taking a tour through this unbelievable experience. We will start from the sun and make our way outwards, exploring the amazing planets, moons, and other objects that make up this fantastic reconstruction. Along the way, we will discuss some of the impressive features of the simulation itself and what makes this project such a big deal. So buckle up and get ready for an adventure through Stellar Journey 2.0. Starting at the heart of the solar system, we have the most important object of all, the star. In our case, it is a recreated version of our own sun. The developers chose to focus on this particular star because it is the closest thing that we have to work with. And they did an incredible job of recreating its appearance. If you were familiar with our sun before entering this simulation, you will feel a sense of familiarity wash over you. That is because the team was able to accurately reproduce many of its key characteristics. This includes things like sunspots and solar flares, which add realism and dynamism to the simulation. But perhaps the coolest feature of the sun is that it actually generates a magnetic field that influences the orbits of the planets. This is a major departure from previous simulations which have neglected to include such an important factor. Exiting the sun, we now enter the asteroid belt. Here we find the first small rocky body that is unique to this solar system, Ceres. It is a dwarf planet that is located between Mars and Jupiter. Ceres has been included in the simulation because it is the largest object in the asteroid belt and also the only dwarf planet in our solar system. These factors make it an important part of the overall system, and by including it, the developers were able to add a little bit more realism to their recreation. Continuing our journey, we now reach the gas giants, starting with the mighty Jupiter. This is truly a sight to behold, as the team was able to recreate its iconic Great Red Spot, a massive storm that has been raging on the planet for centuries. As we fly around Jupiter, we can also admire its many moons, each one unique and beautiful in its own way. One of the most impressive features of this recreation is the inclusion of Europa, Ganymede, Callisto, and Io, Jupiter's 4 largest moons. These moons are not just static objects, but actually have a significant gravitational pull that affects the smaller bodies in the system. This level of detail and realism is what sets Stellar Journey 2.0 apart from other solar system recreations. Leaving Jupiter behind, we now arrive at the next gas giant in the simulation, Saturn. Perhaps the most famous feature of this planet is its rings, and I'm happy to inform you that the developers did not disappoint when it came to recreating them. Flying through the rings is an experience in itself, and you will feel like you have entered a whole different realm. Another cool feature of Saturn is that it has more known moons than any other planet in the solar system. With over 80 confirmed moons, you could spend hours exploring its diverse range of satellites. Some of these moons are small and irregular, while others are large enough to be considered major moons. The simulation includes a selection of the most interesting moons, allowing you to experience the full range of Saturn's lunar diversity. Moving on, we now encounter Neptune, which is the furthest planet from the Sun in this simulation. It is an ice giant, and the last of the large planets in the solar system. Much like Jupiter, Neptune also has several known moons, and again the developers have included a selection of the most interesting ones in the simulation. So far, we have seen a variety of different types of celestial bodies, but now it is time to explore something truly unique. Located beyond Neptune is the Kuiper Belt, a region of space that is home to many small icy bodies. It is here that we find Pluto, the former ninth planet from the Sun. While it was reclassified as a dwarf planet in 2006, Pluto is still an important part of the outer solar system, and the developers felt that it was essential to include it in their simulation. Exploring the Kuiper Belt is a fascinating experience, as you never know what you might come across. There are many other dwarf planets in this region, as well as countless smaller bodies. Some of these objects are newly discovered and only recently added to the simulation, providing players with a sense of exploration and discovery. As we venture even further into the depths of space, we come across the Oort cloud, a theoretical sphere of icy bodies that surrounds the solar system. While we cannot see the Oort cloud directly, we can observe the effects it has on comets as they pass through it. This is another area where the simulation really shines, as the team was able to accurately model the behavior of comets. These icy visitors from the outer solar system are a reminder of the dynamic range and complexity of our cosmic neighborhood. Finally, it is time to leave our solar system and venture into the unknown. At the edge of the simulation, we find ourselves surrounded by the vastness of space and the darkness of the interstellar medium. As we look back at the solar system we have just left, we can appreciate the beauty and complexity of our cosmic home. This journey has taken us to the farthest reaches of the solar system and beyond. Along the way, we have seen wonders that are sure to inspire awe and wonder in all who experience them. From the majestic gas giants to the icy dwarf planets of the outer solar system, we have journeyed through a cosmic landscape that is both familiar and strange. The purpose of this simulation is not just to entertain, but also to educate and inspire. The team behind the project hopes that by creating such an immersive and realistic experience, they can help people better understand our place in the universe. There is still much that we do not know about the solar system and the universe as a whole. But thanks to projects like Stellar Journey 2.0, we are constantly learning and discovering new things. This brings us to the end of our tour of Stellar Journey 2.0. I hope that you enjoyed seeing this incredible simulation and that it has inspired you to learn more about the solar system. Thank you for joining me on this journey, and I wish you all the best in your own exploration of the cosmos. One of the best things about this solar system recreation is that it has been created using artificial intelligence. This means that much of the heavy lifting has been done by machines, allowing the developers to focus on other aspects of the project. AI has been used to generate many of the images and videos that you have seen in this video, as well as to simulate the behavior of celestial bodies. This use of AI is a sign of things to come, as more and more projects utilize the power of machine learning and other technologies. Overall, the use of AI in this project has been extremely beneficial and has allowed the developers to create something truly special. The sheer amount of detail and realism is what sets Stellar Journey 2.0 apart from other solar system recreations. The developers have clearly put in a lot of effort to make this simulation as accurate and immersive as possible. From the behavior of the planets to the composition of the asteroid belt, everything has been carefully crafted to give players a true sense of what it would be like to explore our solar system in person. This attention to detail is evident as soon as you launch the simulation and are greeted with a stunningly realistic view of the Sun and its surrounding planets. Another thing that really stands out about Stellar Journey 2.0 is its educational value. The developers have clearly done their research and have included a lot of information about the solar system in the simulation. For example, each planet has a detailed info panel that provides information about its size, mass, and other characteristics. There are also various other features, such as a compass and a scale, that helps players to understand the relative sizes of the different objects in the solar system. Overall, this simulation is a great resource for anyone who wants to learn more about our cosmic neighborhood. And finally, I want to talk about the overall presentation of Stellar Journey 2.0. The graphics are top-notch, and the simulation runs smoothly even on lower-end computers. The user interface is also very intuitive and easy to navigate, which makes it easy to get started even if you have never used a solar system recreation before. Overall, the presentation of this simulation is excellent and does a great job of showcasing the beauty and complexity of our solar system. In conclusion, Stellar Journey 2.0 is an impressive feat of software engineering and a great example of what can be achieved when a team of dedicated developers set their minds to it. Whether you are a space enthusiast or just someone who appreciates a well-made simulation, I highly recommend checking out Stellar Journey 2.0. You won't be disappointed.